Hello. I'm going to talk about how to use Vertx with Kotlin. But first, a little bit about me. I've been writing Java for over 20 years. I've been a Kotlin developer for 3 years since joining Cody, and I've been working with Vertx for 4 years. Cody, my company, is a financial services startup. We are a remote-only company. We're based in the UK. The code for this talk will be in my GitHub repo. So if I could just have a few hands. If anyone has heard of Vertx, I've got a few. Anyone heard of Quarkus? OK. Did you know Quarkus was based on Vertx? Spring Reflux, I'm sure everyone's heard of that. And Ktor, obviously. All of those are based on Netty, and they use Netty for the non-blocking I/O. So under the hood, everything is basically the same. Vertx is slightly different, though. And part of this talk, I'm going to walk through a small project that I've created that uses Vertx. So the main method creates the Vertx instance. Only one instance of Vertx is needed for the whole application. Vertx supports multiple event loops. And when you create a Vertx instance, it creates the event loop thread pool. Each event loop thread can handle many requests. After starting Vertx, the main verticle is deployed. The application logic starts in the main verticle, and each verticle has its own event loop thread pool. Deploying the verticle takes time, so Vertx returns a future. A Vertx future has an onSuccess handler and an onFailure handler. We don't need to use the onSuccess handler here, but we do need to use the onFailure handler because deploying a vertical can fail. So in this case, we catch the exception and we exit the application. The main vertical uses a Vertx coroutine context, allowing other verticles to be deployed. When writing a coroutine vertical, you override the suspend start method to perform the work when it is deployed. Vertx automatically stops all servers and verticals during application shutdown, so you don't need to worry about cleaning things up. I have structured this application around two service-specific verticals, one for web and one for gRPC. I can use the co-await extension function here to wait for the future to complete after deploying the vertical. Co-await returns the result on success or throws an exception on failure. Using co-await avoids highly nested reactive code. And if one of the verticals fails deployment, the exception thrown will be caught by the main method, and then the application will be shut down. So here is the web vertical, and it creates a web router which forwards HTTP requests to registered handlers. Many different routing criteria can be used together, such as the method, path, or content type. Here I'm using the get method and the attendees path, and this vertical uses the coroutine router support interface, which introduces a correspond extension function. Correspond launches a coroutine using the Vertx dispatcher when the request is received. The Vertx dispatcher makes sure that the coroutine runs in the same thread pool as Vertx. And here I'm calling an attendees suspend method. So the router is configured as the request handler for the HTTP server, and the listed method binds the server to a port, and Vertx returns a future, but we can use co-await here. If the port is already in use, then the exception thrown will cause the application to shut down, which is what you'd expect. The attendee suspend method uses the routing context to gain access to the HTTP request and the response. The GET request doesn't contain a body, but it does contain a path and query parameters. The OK response is set up with a content type header, and the encoded JSON body is returned when the response ends. If the attendees method fails, then the exception can be converted to a custom error response. So in this case, I'm returning a 500 error with a message. The Vertx Kotlin JSON builder makes it easy to create custom JSON objects and arrays. Manual mapping is really useful when you don't want to create a data class that matches the response body. So here, the response from the database is mapped into an array of JSON objects. This is the client, and I'm sending the web request using a shared client to an absolute URL. But you can configure the client with a fixed host and port, and then use a relative path for each request. The send method sends the request and waits for the web response. And you can see again, co-await allows the code to be really simple and logical. The HTTP status, headers, and body are available on the response object. So the response object here is converted to a Vertx JSON object, which is a Vertx native processing of JSON. Vertx uses Jackson for object mapping, so you can configure Jackson however you want using the standard Jackson methods. The JSON object here is mapped to a data class, as you can see. So this is the gRPC coroutine vertical. Vertx gRPC server is used to register the service methods. The services can be grouped into different verticals, which spreads the load across the different threads and the different event loops. The gRPC server is registered as a request handler on the HTTP server, and the server is started again with the listen method. I'm using a vertical for each service, and it's a really nice way of separating the code. The call handler here is used to register each service method, and the gRPC request is forwarded to the handler. The request handler method has access to the request and allows the response to be returned. In this case, a new coroutine must be launched using the Vertx dispatcher to handle a request. Here I'm calling the check suspend method within this coroutine. So this is the check suspend method. I'm querying the database here, and before calling the database, the gRPC request is automatically converted to an object, so it makes the code really simple to use. A valid result is mapped to a response using the generated attendee builder, which gRPC gives you, and then this is returned to the client when the response ends. In the case of when an attendee isn't found, a null is returned from the database, and this is mapped into a not found response status with an appropriate message. This is the client side of gRPC, and again, I'm using a shared gRPC client here, and we send requests to the server using the address of the server and the method that you want to send it to. This method, the request method in this client resolves the address, so it needs to return a future, as you can see. The check request builder is used to build up the request object, and then this is sent to the server, and the method waits for a response to come back. And the response body is retrieved using the last method on the response object if the status is OK. If the status is not OK, then an exception is thrown by Vertx in this case. So you have to check the status first. In the case of an error from the service, then you can map that to a custom status code and message. And that's accessible on the response object. So this is the database. So one of the cool things about Vertx is that it not only handles web and gRPC, it also does database connections and other messaging system connections. So here I'm using the Postgres database connection builder to build up the connection pool. Connection pool is tied to Vertx, and it's automatically released when the application is shut down. So the Kotlin builders make it really easy to configure the different parameters that are needed to connect to the database. And you can see that it's very Kotlin idiomatic. And this is within one of the database repository methods. This is the with connection Vertx method, and it executes the query given a pooled connection. The connection is released when the query completes. The with connection method provided by Vertx expects a future. So I have to use a Vertx future function to launch a coroutine, and then that uses the Vertx dispatcher, and that returns a future that the with connection can use. So Vertx provides support for SQL templates, which makes it really easy to build prepared statements with named parameters. Executing the query returns the future that completes with the row set. In this case, I only need one record, so I can use the first or null function to get that record and then map it to a data class. So Vertx provides also a with transaction method. This manages the transaction, committing automatically on success or rolling back on failure. Under the hood, the transaction uses a connection from the pool. Again, the with transaction expects a future, so we have to use the Vertx future function here. This example uses the prepared statement with positional parameters instead of an SQL template, just to show you that the different types are supported. The prepared statement is converted to an executable query that is then executed with values from the tuple. The query result is returned to extract the generated ID in this case, but if the record isn't created, then no rows are returned. A valid result is mapped to an attendee in this case, or null if there's no attendee. So here's finally the data class that allows the attendee to be returned, and I have a mapping extension function that maps from a database row to an attendee. Vertx maps the complete set of the database types to equivalent Kotlin types, and you can access fields using numbers or names, depending on whether you have a single parameter that you want to extract or multiple parameters. So here is the complete code. You're not expected to read it, although it does look pretty well on this big screen. Just to show that there's no surprises. So this is the main application and the web vertical. This is the gRPC vertical and the client. And finally, here's the database pool and the repository methods. So it's really simple, really clean code, and it's performant because it runs on Netty. And here's the link again to the GitHub repo if you want to get started using Vertx with Kotlin. Thank you for listening, and please use the conference app to send feedback.